Okay, Dennis, take it away.
All right. Well, let me just, yeah, I don't have much here. Okay, yeah, I got it. All right, so let me share this screen here. All right. So do you guys see my PixInsight workspace?
Yep.
You do? Yeah, okay. All right, great. Yeah, I won't actually run. I'll show you the deep field. Yeah, so here's the published deep field image from Webb, and one of the things that I wanted to test out on Star Exterminator is that would it actually deal with these kinds of really severe artifacts, and so I won't run it, but this is the GUI right here, and you actually have a choice of three different versions. This first one here is the full AI with the small analysis windows, and boy, this one takes a long time. In working on the Webb image, it took close to about 5-6 minutes in order to process the image. So I won't run it. There's a light version which analyzes a little bit larger cells within the AI, and it shaves a minute or two off, but it's still pretty pretty long. I haven't tried this one. This is kind of the light version, but and no noise reduction. But I haven't tried that one, so I can't speak for that one. But the one I use, because I've got plenty of time on my hands, is I use the full AI version. But and literally it's pretty easy. All you do is just drop it in there and then go for coffee. So I did that just this afternoon or yesterday.
Hey, Dennis.
Yeah.
Just real quick question.
Yeah, sure.
Does this process work on linear data only, stretch data? Is it sensitive to that, or it doesn't care?
Oh, okay. So it's interesting. The recommendation is to use this. I'm using this on nonlinear data. This is like the last step. For example, oops. Let me just close this. So whether you can use it on, I'm not sure why you would use it on the linear version of that's too far upstream. I mean, you're trying to, yeah. So for example, this is the one I'm going to do the demo on. This is the last image I did, and so it's the last thing I do, and so obviously this is a nonlinear image. But when I run Star Exterminator on this one, it actually comes out looking really nice. Now you need the Star Exterminator or StarNet because you do need a starless image to do the star reduction, and so I'll show you those steps in a minute. But So let me just minimize that. So I'll get to that with the stars. So here's that deep sky image, and then running the full version of Star Exterminator. Wow. It does an incredible job of cleaning up this web image. I mean, even this monster, which was right about in here, and all of the diffraction spikes, but it just makes for just a gorgeous image. So if you're,
did you preset those diffraction spike settings before you ran this, or is it just figure it out? Wow.
No, the AI, this new AI 11 in Star Exterminator basically has been, and I wanted to test this. I forget, Gabe, maybe you know who the author is of Star Exterminator.
I forget his name.
Yeah, I do too right now, but he claimed that he's tested.
Yeah, that sounds right.
Who was it?
Russell Croman. Yeah.
Yeah. Okay. He claimed, he tested this AI version 11 on everything, including web images, and I going, yeah, really? And so, but my goodness, it really works outstanding.
Seems like it knocked out a couple of bright stars, right?
Well, it took out all the stars along with their diffraction.
Yeah, I was trying to determine if it was a galaxy or a star. It's incredible. So, James Webb.
Yeah.
Cool.
Yeah, I had to see it to believe it for myself, but it does a nice job, because when I talk about the web deep fields, I'm now going to use these images and run the Star Exterminator on these images, so that I'm only talking about galaxies. Yeah. So anyway, I thought that was interesting. It's one hell of a product. I think it's like $69 I forget what the cost is.
$59.99.
$59.99. Yeah. Okay.
I'm looking at the website now.
Yeah. All right. So again, the star reduction program also works really well from Bill, and these icons are readily available from and I can give you guys a link or actually provide. I downloaded. It's one of the icon process extensions, and so if I open up, this is just where I've got it located on my drive. I can post this in Slack very easily. And literally, there's just nothing to install. I mean, once you have this downloaded and put in a file someplace, all you have to do is carry this out, and it'll add the 3 processing icons right to your desktop, and then just go along and save the process icons. Just like you would do normally as you build your process icons for PI. Okay, so I already have these installed here, so I don't need a second set. So let me just delete these. And so, boy, this thing is really easy to use. The first thing you do is open up the image that you want to reduce the number of stars. And obviously there's way too many. I mean, there's really quite the number of stars in this particular image that it blocks a lot of the nebulosity. I'm not one to go all the way to no stars, but so the first step is to use this icon here that says clone for starless. And literally all that's doing, I mean, you guys know how to clone. I mean, I could take something over here and clone it that way. But what this icon does is it literally makes a clone, but then renames it for the image file that his pixel math needs. And so it's just a little convenience. So it not only makes the clone, but then also renames the image so that pixel math knows to recognize that. At that point, you then would use either StarNet or Star Exterminator, and I won't do it here because it may take too long. But what I would do at this point is just drag this in here, get rid of all the stars, and literally end up with this image right here. And so with these two images open, I'm just going to put this guy down here. I now can close this. I don't need that anymore. And so he has 3 different pixel math versions, and I've tried them all, and I don't really see a big difference between the two. Now there might be some types of images where you would use the other 2 methods. I can give you guys a link to his detailed explanation of the subtle differences between these 3 methods. But just out of the gun, literally all you have to do at this point is just drag it, and there's the star reduction. Okay, and as you can see, it does a really nice job. Part of it is based on the quality of the starless image. So there's the previous version, and there's the reduced stars. Now you can actually go in here and adjust the amount of star removal or star reduction. So if I make this number a lot smaller, it's going to take out far more of the stars. So let me just drop this down to 10. Go back. And probably a pretty subtle difference, but I can go in the other direction. So if I make this 30, let's say, go back, it's going to leave far more stars in it. So it's dialable to where exactly you want it. So. And boy, like I said, I can drop this PI icon, process icon in Slack, and make it available, and so you don't have to go to his website or anything. You can just download that one file and drop it on your desktop or your PI workspace.
Seems easy enough.
Yeah, I mean, I'm all up for easy. I just think it just does an outstanding. Now I've been running with the default, which is 15, and boy, that just seems to be just a nice sweet spot. And boy, that just makes for an outstanding improvement in the image. So that star reduction, free of charge. It's really a no-brainer. Now you do need either StarNet. Now I started doing this with StarNet, and but Star Exterminator just makes for just a much nicer starless image. But you do need that starless image, and it does need to be named starless for all this to work. Okay. Any other questions?
I dropped a link to where you can download that star reduction file in the chat in case anybody wants it.
Oh, okay. All right, cool.
Right under Gabe's link to Star Exterminator.
Yeah, okay. All right. So will that take you to his Dropbox where you just download?
On the PixInsight forum, he's got a link to it right there.
Yeah, okay. Good.
Took about 10 seconds to download.
Yeah. Okay, yeah, I could have put the file in Slack as well. All right. Let me stop sharing here.
Really cool.
Yeah, it does a nice job, and boy, and so does and so does the so this is the Star Exterminator version, and wow, it's incredible how accurate this AI is. Well worth the $59, for sure. And you can use this for the star reduction pixel math as well.
Which version of PixInsight are you running, Dennis? Do you have the newest version running?
I do.
I've been leery of upgrading to that newest version because I've heard about problems with like all the different plugins. I use the Easy Processing Suite a lot and things like that, and I don't want to break anything that I know works.
Okay. Let's see. I am running 1.8.9-1. Is that's probably the most recent, right?
No, I think 2 isn't 2.0 the newest version. Gabe or somebody might know.
Boy, I haven't seen it.
I think that's the same version I'm running. 1.8.
Yeah, because usually when I open up PixInsight, if there's well, let's see. Updates. Check for updates. Yeah, no, there are no new updates currently available for your PixInsight installation. So I think this is the latest.
It's the same one I'm using.
That's what I'm running. Okay.
In fact, when I was on the NASA forum, I asked them what version of PixInsight they were using, and it was the same version, the 1.8.9. Okay, so let me stop sharing. So that's I was most impressed by what it did with the web image. I'm actually going to be using that starless image tomorrow in my class at Carroll.
Using the MIRI sensor when you download those images from the website, the web as in James website, not web like website.
Yeah. Here, I'll show you. I can quickly show you the link that I use. Let's just go to just store it. Just bear with me for 1 second here. All right, so I'm getting all the images. Let me just.
Are you downloading the raw files, or are you downloading the final images and then just working with those?
Yeah. Okay. So no, I'm taking the raw files here. Let me share my screen again. How do I do that? Where did my I lost my share screen.
Should be a green button right in the middle of the bottom.
No, I mean, all I'm seeing is the. Oh, here it is. Yeah, no, I had everything minimized. Okay, so I'm getting everything from mass.stsci.edu.
Mm-hmm.
And they are actually using 1.8.9-1.
Yeah, that's the newest version.
Yeah, so if it's good enough for NASA, it's good enough for me. All right. Okay, Kevin, it's back to you.
So I was wondering, you just showed Star Exterminator, and there is a way of getting the a graphic processing unit, an NVIDIA kind or model, I should say, to accelerate that. I'm wondering if others have tried that. I tried it with my desktop back in Wisconsin, and it made a dramatic difference. And I think there was some chat on the on Slack about it a couple of months ago. It's a little difficult to do, especially if you don't follow the directions, which happened to be 3 times. But if you follow them correctly and you have an NVIDIA GPU, it can accelerate it quite a bit. I'm wondering if others have tried that and would like to comment on that if they have.
I don't have an NVIDIA card in my computer.
Yeah, and it will only work with the NVIDIA cards. I have a older one, a 1070, and it made a dramatic difference.
Yeah, I heard about that discussion and actually followed the link to the instructions, and it was way outside of my wheelhouse and it just seemed so risky. Just too many steps to do that acceleration.
Yeah, it does make a dramatic difference, but I killed off Pixel Insight. I mean, it would just quit running when you'd make a mistake. And I went through that 4 or 5 times, and I wasn't literally following the directions because they were a little bit difficult to follow. But once I was able to do it, it worked very, very easily. And on the PixInsight forum, Russell, is it Croman? He gives a link to the instructions on how to do it. And I think they were originally developed for StarNet, because it works for both. Because they both use the same sort of AI process, and this accelerates it. So the other thing, kind of corollary to what we were talking about, is, and Dennis, you kind of alluded to it, that you like Star Exterminator better. And, you know, there's Star Exterminator, StarNet, there's some stuff built in with PixInsight. What are people using these days, and what are people's thoughts on what works best for them?
I haven't been able to successfully remove stars from any of my images. I've used StarNet and it doesn't work. I always get a lot of artifacts and things on the images when it's done processing. I just gave up on it. So the Star Exterminator is going to be interesting. I just downloaded the trial and I'm going to try it and see if it works better.
I used to have StarNet, but then when I upgraded my software, it went away and I never bothered putting it back.
There's actually a StarNet 2 now, but I think from everybody that I've looked at through all of the links on Star Exterminator and some of the YouTube videos, boy, it was a no-brainer for me, and no artifacts, and it just works really, really well.
Yeah, Jim, and I did a side-by-side before I purchased it, and I saw the artifacts on the one. I didn't see them on now. Star Exterminator.
Yeah, StarNet has a lot of artifacts that are difficult to get out. I used to use StarNet, and now I use Star Exterminator almost exclusively. To answer your earlier question about GPU usage, I don't have a NVIDIA GPU, but I know that the Star Exterminator does work on a Mac, the latest Macs, the M1 and M2 Macs, and it uses the internal GPU to accelerate computation there. And it's seamless, so you don't have to set up any drivers or do any installs or anything like that. So I did it on this web deep field, and it took like a minute and a half to run through the image.
Yeah, somebody asked about the download of the web images. Now, the nice thing about what they've done is when you go to that site and you navigate to, I mean, that site is for downloading images from virtually every spacecraft. I mean, you know, from Hubble images to TESS. So once you, and it's pretty self-explanatory. You know what spacecraft you select, and what image within the different cameras. You do have to select which camera you want to download the image from, and but when you get the files, they will give you the raw images, but they're already been calibrated, and so you don't have to do that part, and so because I imagine the calibration piece is probably pretty complicated. So what they consider raw images have already been pre-processed.
Star Exterminator isn't flawless. I was doing the same thing you did, Dennis, with the Webb Deep Field. I think you can see my screen.
Ah, okay.
And
Oh, you just
yes.
extracted the stars.
Well, this is the original, and I
Yeah.
got the star list, and then the difference gives you the stars.
Yes, right.
So if you zoom in, you can see some, like there's a galaxy here. There's some other like nebulosity or something going on in here. So it's not foolproof, but it still does a pretty good job.
Mm-hmm.
I think some of these redder objects are probably actually galaxies that are very far away.
Yeah. So did you say generate star image, or did you just subtract the two images?
I just subtracted them. That's what I usually do. It's a more manual process. I think if you click this, you get both. So maybe I should be using that, but
Yeah,
it's just an old habit.
Yeah, it'd be interesting to see if just generating the star image is cleaner than subtracting the two.
I think it should be identical, but we can test that.
Yeah, let's see. Since you got it is so fast.
Yeah.
So the one that's still on the screen is your manual subtraction.
Yeah.
Yeah. Okay. Good.
Hey, this isn't related to star reduction and star elimination and that sort of thing, but since we're talking about pixel math, Gabe, if we have time toward the end, if you could show me again how to combine like an HA and an O3 image in pixel math, I'd appreciate it.
Mm-hmm.
I was trying to do that the other day, and I was looking it up online, and I was having a lot of problems. And I thought it was as simple as image 1 plus image 2, or you could do like 80% of image 1 plus 60% of image 2, but I couldn't get it to generate an image, and I don't know what I was doing wrong.
There are a lot of different ways that you can go about combining HA and O3. I have a pixel math thing down here that I use for that purpose, but I think it's a simpler version than some of the ones out there. Like some of the ones out there will take into account bandpass of like O3 filter compared to like a typical luminance filter and things like that.
Jim, did you select the option where it says create new image?
I did. It was failing. It kept throwing an error message, and I couldn't figure out what the error message was. What I was doing is just to fill the time. Okay, well, we can stop and look at this first. I see a lot of those same galaxies and things in there.
So let's come on. Create a preview. I'll just toggle between them. There is some difference. This was the manual subtraction. This was the non-manual subtraction. So it looks like manual subtraction does a little bit better in terms of the brightness of what's left over and the color too. And so that's surprising actually.
Yeah.
Huh. Weird.
Cool.
I'm toggling between these and you really can't tell much of the difference. Yeah, I can't see any difference at all. So there must be some extra post-processing done after the subtraction for these two. Yeah, for those two.
The automated star image is less bright than the manual.
Yeah, so this is the automated star image, and then this is the manual star image,
Oh,
automated
okay.
manual.
Yeah, that is surprising.
Let me see if I'm not like in a screen transfer function thing. No, they're both zeroed out. So yeah, something else is going on when you generate star image. Interesting.
I would have thought that the inverse would have happened. If anything, the automated would be slightly less bright because he would do like some percentage knockdown to hide artifacts that he knew was happening.
Yeah. Yeah. Weird.
But the automated is less bright, right?
No, the automated is brighter with higher higher saturation. Let me go to stars.
Interesting.
And then
Okay.
this one. So this is the automated, and then this one is the manual. So it's brighter, and you see in these starbursts that the colors are more saturated too. Yeah.
Oh, you're fine. Nothing.
So before we leave stars, and talk about the pixel math on the combination, what are the primary reasons you separate stars from your pictures? What are you primarily trying to achieve? And not an exhaustive kind of summary, but just a few examples for the group.
I don't separate my stars.
The easy one is, in some instances, I kind of just like the images better without stars. They look cool.
That's my case. Yeah.
Another example. I know not everybody does this, but sometimes it's maybe easier to remove the stars, work on the nebulosity image, and develop that more, and then add the stars back in, so that you're not applying those processes to the stars, or you don't have to create, fancy masks and stuff like that. So sometimes it's easier to enhance the nebulosity and not disturb the stars.
Some people also, the reason I want to do it is because I use a one-shot color camera with like an L-Optolong, L-Enhance, or L-Extreme filter to capture the HA and O3, and it gives you a really funky looking star colors. So you take RGB stars and the narrowband, and you take out the narrowband stars and add in the RGB stars when you're done processing to get better colors.
So you're swapping them out?
Yeah, you just do a starless of the nebulosity or galaxy or whatever it is that you're imaging, and then add in RGB stars at the end.
So pixel math to do that?
That's the concept. Yeah, I just haven't been able to. But I actually ran across a tutorial about a week ago on how to use pixel math to extract almost a pure HA and O3 channel from the one-shot color image based on your camera specifications at certain wavelengths and the filter bandpass. And I was able to extract an HA and O3 image using that from my one-shot color image. But when I tried to combine them, I couldn't get them to combine. I kept getting an error message. That's why I was asking. I wanted to compare it to just with just my normal processing of a one-shot color image through that filter to see if it looked better. Because if it looked better, I would start to do it this way. You physicists would probably enjoy that because it's very math intensive. There's a lot of formulas and things.
So Jim, I'm confused. You have a one-shot color camera, and so when you do your nebulosity, you're not adding any narrowband filters on top of your color.
No,
camera.
but there's the filter I use for the one-shot color it has a better pass at the HA and 03
Oh,
bandwidth.
okay.
So there's pixel math you can do to that one-shot color image to extract just the pixels or most of the pixels that fall within that one range. And you get the concept is you get a truer HA image and 03 image than you would if you just took the one-shot color image that was taken with that filter and processed it. It allows you to really boost up the HA and 03 and combine them and get rid of all the other stuff or minimize all the other stuff that comes through the filter. That's why I was experimenting with it to see how it really worked. The tutorial I was watching, the guy did it and it looked pretty good on his, and I wanted to see how it worked with one of my images. And I got to the point where I was able to extract, the false HA and 03 image, but I couldn't get them I couldn't combine them. Because I was getting errors in pixel math when I tried to run it. I was getting some strange
do these one-shot color cameras have IR filters?
No, not typically. Mine doesn't have a built-in IR filter. If I'm doing RGB, I'll throw the IR filter on it and use that.
Okay.
Sometimes. I have an IR cut filter I use in certain circumstances. But those filters, those optolong filters, even the light pollution filter, they add some false color and some strange colors into your images at times, greenish stars and that sort of thing. And it's, just ways to try to make the images look better.
Yeah, you don't want green stars. That's actually a test question for my students tomorrow. Why are there no green stars? All right, so Gabe is going to show us how to combine your images.
Actually, there's one thing I want to show, which before that, there's a question about what do we use starless, these starless filters for? One is, like Jeff was saying, that just, you like it. It's a nice view of of that section of space. The other is, it helps with processing to separate stars and nebulosity, and you can process them differently. But another cool thing that I like is that when you go into an image like this is one that I'm working on. This is a quick process of LBN 534, also called the checkmark nebula. And if you apply starless to this, you get to see a lot of extra stuff that's just not as present, not as pops out of the image with all the stars kind of in some way contaminating the field. And this is the starless. So you see a bunch of these little galaxies out here in this image, along with the fainter nebulosity in the background. And then this little guy, I'm pretty sure, like if you zoom in, not that far, but you zoom in, I think that's a planetary or some weird galaxy, but it looks circular enough that I would be willing to bet that's a planetary. Where if you just look at this, you're not going to see that stuff in your image. Right. But once you have that perspective and you can see something like this, you can go, yeah, there's a galaxy here. And then there's that little planetary looking thing. Where is it? Over here. So that's one thing I like to do with the starless images, is just look around to see what else is out there. And you can't really do that as well with all the stars everywhere.
Oh, just as an aside, Jeff, are you still online? Oh, yeah. You commented that you didn't see the check mark?
I think he was joking.
Oh, okay. I was
at least I reached out to him after. I'm like, hey, were you actually saying that for real? Or and yeah, he was joking.
Oh, good. Phew.
Yeah.
It sounded like a neurological disorder.
Not like the Wizard Nebula, Dennis. It took me like a year and a half before I saw the Wizard in it.
Right.
Just Gabe, real quick question on what you showed. Do you use the defaults for SAR Exterminator generally, or do you play around with this?
I haven't found a need to play around with it very much. I'm usually tolerant of that stuff. I don't, unless I see a strong reason to change those things. I don't.
Thanks.
Gabe, have you played with all three versions, the light and the light noiseless, no noise?
Yeah, in terms of what you get in the end, they're all pretty close. The lighter you go, the faster it is on your computer. So if you just want a quick and dirty version, you can do the light version and it'll run in a fraction of the time. Can you see the pixel math window?
Yes.
Okay. This is dead simple. This is all I have. I'm not using single RGB expression. So that means that each channel has its own expression. In this view, I would have two channels, an HA and an O3. Let me see if I can pull one of those out. Maybe I have an image or a set here that I can get some. Sorry, this is very ad hoc and I don't have anything prepared.
No, I appreciate it. I know you weren't planning on doing this. And I didn't want to derail the meeting. I mean, if there's other stuff to cover, do that first. I just thought if we had time.
Let's try.
Not often you get this many smart guys in the same room.
I don't even know if these are aligned. Let's see if there's a different version or a different object that I have hanging around here. Yeah, this one's probably more punchy, I would say. This is the Tulip Nebula. Actually, I never did. I know Chad did a version of HOO on the Tulip. I didn't get a chance to. I think these are stacked. Yeah. Okay. So I'll rename this one HA. And then rename the other one O3. And so each of these channels has an expression. So for red, I'm just putting it all HA into red. For green, I'm doing O3 plus some fraction, HA green. So HA underscore G for that. Likewise for blue. And then under symbols, I can vary the fraction. And then I create a new image and call that HOO. And we'll see what happens. Okay. So I need to get sorry, I'll change. Did the screen go away or is it still there?
It's there.
Still here, just really big.
Yeah, sorry. All my icons are over here, so yeah, something like that. So in that way, with these fractions, you can change these to adjust like the shading of the red and the blue or the green and how you adjust those. So you can play with these values. You can also add it to the red channel. I just usually push all HA to the red channel. And I can send the process icon as well, if you like, Jim.
Yeah, that'd be cool. I can play with it. That'd be awesome. Thank you.
Sure. think I have another, let's see, SHO. Oh, that one's just dead simple. It's just, there's no weighting or anything. It's just combining them in the same kind of 100% for each channel. Yeah, I can send the HOO combined channel.
Great. Other things that people have questions about or want to share this evening? I'll just mention something about 10 days or so ago. I posted a picture on Slack because I had oval stars. I found that my tracking PhD2 somehow some of the things over the summer, gremlins must have gotten in, changed some parameters. I got that all cleaned up. I got tracking working better than it ever has. I still have oval stars, and it doesn't matter whether I'm at 900 seconds or 300 seconds. And so the other night I rotated my camera 90 degrees. And sure enough, all the stars went oval 90 degrees. So I still have some more testing to do, but what I'm afraid of is that I have tilt perhaps in my camera or somewhere in my imaging train. Does that seem to make sense?
It does, yeah.
So let me parse this again. You rotate the camera and the star's orientation, that elongation orientation changes on the frame.
Correct.
Okay. Yeah, that's not the camera. That's your imaging train.
Oh, okay.
Yeah.
It's not PhD.
Let me be clear. I didn't change the camera. I changed using the rotator. I changed, the filter wheel, the camera, the reducer. They all changed by 90 degrees.
I see.
So does that still mean it's in the train?
It could be that there's tilt between where that rotator is and the lenses in the telescope, or it could be an issue with the lenses themselves. Perhaps collimation or something might be off. But yeah, that does rule out, like Mike was saying, that does rule out guiding issues like PhD or anything like that.
Yeah.
Was it the same night?
Yeah,
Okay.
Same night, probably, 20, 30 minutes apart. And because once I got the guiding going, I was comfortable that it was guiding, extremely well. I still saw the egg shape, and it was there, and it was pretty much all over the place and all pointing in the same direction. And that's when I just went out, rotated the whole assembly with the rotator on the TAC 130 because it has that CCA device, and then took a couple more pictures, and I focused each time that I refocused, and I even tried a different filter because these were hydrogen, and then I did a couple in sulfur. So, changing filters didn't seem to have any effect.
You try different spots of the sky, see if it has anything to do with gravity pulling down on something? Anything shifting?
No, that's a good point. The moon was out, and I found kind of a dark spot, and I shot at that. And I can't even think right now what the object was. But no, I can, I certainly can do that. Probably tomorrow night I can do it. Tonight it's very windy here. 25 mile an hour winds, so a little breezy. Although it's clear, you know, that's what they put in the real estate ads. You know, you get all these 300 nights of clear weather down here. They don't mention the hurricane winds.
So, can I ask a question about the frame inspector, Gabe?
Yeah, sure.
Yeah, I want to get a little better understanding. You can do a heat map of eccentricity and ellipticity, and the two maps are dramatically different. And I guess I'm just trying to get a handle around. I know the formula for ellipticity and eccentricity, and it's really the same horse measuring it two different ways. And I'm just wondering why one map would look fairly normal. And I got an example I could share, but this is a more generic question. Why the maps would look so different? Why the ellipticity map would look fairly normal with very low values of ellipticity, meaning closer to a circle. But then when I flip to eccentricity, boy, the map goes to the other end of the scale and the numbers are up like 0.4, 0.5, 0.6, and it really looks horrible. So I'm confused on why the two measures of this relatively the same thing are so different. Does that make sense?
Yeah, they are two different measures of the same type of thing, as you say, but
yeah,
but internally, when we let me real quick bring up
oh, there we go.
All right. So this is the ellipticity, eccentricity. The ellipticity and eccentricity are different measures. They're trying to measure how flat the star is, or how far away from a perfect circle it is. Each one of these boxes is a grid box that contains a number of stars in there. And when you construct an aggregate value to represent that grid box over all the stars in there, you have to ask, how are you going to aggregate it? And that's where the difference is coming. In the eccentricity, I'm aggregating as a scalar, meaning it's just a number and I'm averaging them. Kind of what you would typically associate with like a pix and cite analysis.
Okay.
With the ellipticity, I'm taking the vector sum. So it's an elongation in one direction, and that elongation has a magnitude and a direction. And so of all the stars in there, I'm actually adding the vector sum of those, and then that's what's represented as the ellipticity in the heat map. So if you have a bunch of stars, say for example, you have within a grid box, you have stars going different ways. The eccentricity will be high because you're taking the scalar sum. They could be in totally different directions, but the ellipticity will start to cancel out, and that'll be a little bit lower.
So
now,
go ahead and switch. Go ahead and switch with this example. Go ahead and switch to eccentricity. Yeah. Okay. That's the same kind of thing I'm seeing.
Yeah. Note also the scale changes from 0 to 1, and the ellipticity I have as default from 0 to half. just to make the colors look, there's some gradation.
You know, funny, I never noticed that the scale is different.
Yeah.
Oh, well,
And then whenever you hover over a box, you can see all the numbers side by side. So in this box, you have 36 stars.
Mm-hmm.
You have an ellipticity of 0.081, eccentricity of 0.433. So they're very different scales, but they're just measuring that. First of all, the relations between them are different, so you can't compare them apples to apples.
Okay.
But the way that's aggregated is also different, and that the eccentricity is a scalar sum and the ellipticity is a vector sum.
So is the aggregation adding more information?
It's just whenever you aggregate, you destroy information. But this is a way that, I mean, I don't know how many stars are in this frame, but let's see, I think it was from this one. This is an 03, so I'll add that. How many stars? There are 4,500 stars in this frame. And so within a grid box like this one has 51, this one has 52. When you get to the edges, maybe there are fewer due to maybe light fall off and so on. But you aggregate all the stars into a box, and the box is a representative of what's going on in that part of your frame. And so that's the idea with that.
Oh, well, the big difference is I never noticed that I just assumed that the scale was always 0 to 1.
Right. If they were both 0 to 1, in both cases, the color scale would be totally different. Which you shouldn't read that as being the same, because they're different properties.
Yeah. Okay.
Not only mathematically a different calculation, but the aggregation is different too.
Okay.
Hey, Gabe, saying if I say it a different way, I don't know if this is the same way to say the same thing, just differently. The ellipticity is not only accounting for the amount of squish, if you will, but also the direction of the squish, right?
Yeah, it's including the more aligned the direction of the squish, the higher the aggregate value will be. Whereas with eccentricity, if they're not aligned, it's still going to be the same. They could be aligned in random directions or all in the same direction. The eccentricity will be represented in the same way.
Yeah. Okay. Thanks.
Yep. Does that make sense?
Yeah, it does, but there's also directionality in both the eccentricity. Let me pull up a slide. Let me just bring this up. Right. All right, so let me share again here. Okay, so can everybody see my slides?
Yep.
Yeah, okay. All right, so ellipticity is you're looking at just the ratio of, or the difference between the semi-major and the semi-minor axes. And so you're getting directionality there as well, because the only difference with eccentricity is you're comparing it to the distance from the center to the focus point of the ellipse, but you're getting the same directionality.
Right. The orientation of this circle or this ellipse is what you're asking. And in both cases, the eccentricity and ellipticity, you can define a direction. And what I'm saying is that when I aggregate the eccentricity,
Mhm.
aggregating it in a different way than the ellipticity.
Okay.
So I could very well switch it and say the eccentricity, I could aggregate that and keep it as a vector sum to keep the orientation.
Mhm.
But I'm not. I'm doing it the other way.
Okay. Okay. I don't think there'll be anybody in the class that will notice that, but I noticed it and it just bothered the hell out of me.
Yeah,
That
no
there was
worries.
such a difference between the two heat maps. Okay. All right. Okay. I think I got it. Because you're going to be famous tomorrow, Gabe. So I'm going to introduce you to the physics department at Carroll.
Nice. Thank you.
Yeah. All right. Okay, so let me stop sharing here.